question number 61. So this question says, consider the following sets of quantum numbers. So we have a table given and 4 quantum numbers are given, L, M and S values. Okay. You have to just choose which of the following sets of quantum numbers are not possible. So basically you have to just choose that option in which the given set is not valid, that cannot be followed. Okay. So we have to check one by one. First of all, I am taking first one, that is A. N value is 4. Okay. If N value is 4, then L value should be 0 to N minus 1. It is there 2, right? So it comes in 0 to N minus 1. Then same for M value, what should be the M value? M value should be minus L to plus L. So okay, let me just write here. If you want to check L value, it would be 0 to N minus 1. Clear? Then M value minus L to plus L, right? And S value none other than plus half or minus half. These are the two values which are possible. So the most important is to check L value and the M value. Okay. So for first value N is 4, then N value can be 0 to N minus 1. So 2 it can be, right? If L value is 2, then M value can be minus 2, minus 1, 0, 1 and 2. So this minus 1 come in those values. It is possible. Then S value can be plus half. So overall if you just check, A is possible. For B, N value is 3. Okay. L value is 1. That's also considerable. But M value is given as minus 2. L value is given as 1 and M value is given as minus 2. Not possible at all. Okay. And if it is not possible, it means B is incorrectly given. I marked cross. Okay. Now let's check C. It says N value is 5. Great. L value can be 3. It is 0 to N minus 1. Then M value is 0. It is also possible because the value of M is dependent on L value, right? From minus L to plus L. It is also feasible. And then S value is plus half. So C is also valid. Okay. Now turn for D comes. N value is 2. L value is also 2. Is it possible? Not at all. Why? Because L value is always less than N. N minus 1, 0 to N minus 1, right? So this is also not possible. So B and D are not possible, and on the basis of that, you can easily choose the right answer, which is option 3. I hope clear it is. Okay. Now question number 62 I am taking. If a particle of mass 10 milligram is moving with the velocity of 600 meter per second, then the de Broglie wavelength associated with the moving particle will be. What formula we use for the de Broglie wavelength? Simple. H by P or H by mv. Right? They're asking about to find out the de Broglie wavelength associated with the moving particle. It means lambda you need to find out. Okay. So is H value given? Yes, it's given in the question itself. 6.6 into 10 raised to the power minus 34. Otherwise, you need to learn this value. Divide it by the mass of the particle. Is the mass given? Yes, it's given. 10 milligram. And if you need to just change this milligram into SI unit of mass, that is kg, right? So how much you need to multiply? 10 raised to the power minus 6. Okay. Now, velocity of the particle 600 meter per second. Done. The values I just kept here. Okay. Now just solve this. If you just solve this entire thing, you will find your answer would be 1.1 into 10 raised to the power minus 31 meter. This is the final answer for the wavelength calculation. And if you just calculate this way, your answer would be option 1. I hope this question is also clear. The turn is for the next question. We have question number 63. Maximum number of electrons accommodated in the orbitals of an atom for which N is 4 and L is 2. So in this case, we have two values given here. One is 4 for N value and L value is 2. So which orbital it is? It is 4 because the principal quantum number is 4 and azimuthal quantum number is 2. So this 2 is associated with d orbital. You're getting it right, 4d. And now they are asking the total number of orbitals of an atom for which these values are given. 4d subshell we have, and if you just look at, you will find that there are 5 orbitals here associated with it, and they're just asking you to find out the total number of electron, maximum number of electron even, right? So the total number of orbital that can accommodate in one orbital is 2. So if we are talking about 4d, there are 5 orbitals. So how many electrons can be there? 5 into 2, 10 electrons can be there, right? So 10 electrons are given here in option 4. You just choose this as your correct answer. Done? Okay. Now question number 64 we have number of electrons present in p orbital of gallium atom is, right? Atomic number is given for the gallium, it is 31, and you need to just find out the p orbitals of the gallium atom, total number of electrons present in p orbital, okay? For the same, I need to just write down the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 10 and 3p1. So if you just sum up this, 10 plus 10, 20, 30, 31. Done? Correct. Electronic configuration is mentioned. Now the question comes, total number of the electrons in the p orbital. Okay, 6 plus 6, then 1. So in total it would be 6 plus 6 plus 1, 13, right? 13 is given here in option 3. So that would be your correct answer. And if you have chosen that, yes, your answer is correct in that ways. Now I am taking the question number 65. Statement 1. Cathode rays consist of negatively charged particles called electrons. Okay. And the statement 2 says the characteristics of the cathode rays depend upon the nature of the gas present in the cathode ray tube. Just recall the cathode ray experiment. The very first thing about it, that cathode rays start from cathode and move towards anode. It means the particles which are there in the cathode are negatively charged particle, and you are getting it right. These are the negatively charged electrons. Okay. So first statement is absolutely correct. Cathode ray consists of negatively charged particle called electron. Right. Now statement 2, the characteristics of the cathode ray depend upon the nature of gas. No, because neither on the nature of gas nor on the type of electrode they are dependent. Right. So it means the statement 2 is incorrect, and if statement 2 is incorrect and statement 1 is correct, the right answer for you to choose is option 3. That's the right one. Okay.